All right, hello again, Spartans. We are going to do some more inequalities. So, as we begin, I want you to read exercise 3. Pause the video and read it. And then we'll read it together when you resume the video. Consider the following two scenarios. For each, specify the variable and say W is the width of the rectangle, for example, and then write out a compound inequality that represents the scenario given. Draw the solution on a number line. So, let's get started. Scenario A. Students are to present a speech in their English class. Their speech must be at least 7 minutes, but not more than 12 minutes. So what are we talking about here? What value or what quantity is important here? Well, I think the length of their speech is the important value that we're talking about. So that's a value of time, isn't it? So let's use the letter T and say T is the length of the speech in minutes. All right, so I got my letter, my variable is T. And then I tell you what that T means. It's the length of my speech. And then here, and I always put that in parentheses, is in minutes. Just like I put it in parentheses when I do a graph. I'm doing it here too. Okay? Now, my inequality is going to have T in the middle. Now, I ask you, can a speech be at least 7 minutes, but not more than 12 minutes? If I say at least 7, that really means more than 7, right? Or equal to 7. But not more than 12 minutes means it can be 12, but it can't be more. But it can be less than, right? So here's what I'm going to do. I'm going to have 7 on this side, and then 7 is less than or equal to T, which is less than or equal to 12. I think this is the first time we've done this, but I got everything in one inequality statement. You may have seen that before. The reason I can do one inequality statement is because a single value of T, let's pick 8 for example. 8 can be greater than 7. It can also be less than 12, and it can do those things at the same time. So I can write it in one statement, okay? So now I'm going to graph this on a number line, and I'm going to start over here at 7. This is 8, this is 9, this is 10, this is 11, this is 12. So that's 12. And then because it's less than or equal to, I'm going to put a solid dot at 7, and because this is less than or equal to, I'm going to put a solid dot at 12. And remember, T can be anywhere in the middle of that. So I am shading in the area between 7 and 12 as well. And I have graphed my compound inequality. Okay, let's go to scenario B. Children and senior citizens receive a discount on movie tickets. To receive the discount, a person must be between 2 and 12, including ages 2 and 12, or 60 years of age or older. Now, the big important value in this one is age. Okay, so let's use the letter A for age. So A is age, and in parentheses, in years. So that's the units that I'm measuring in, is years. I put that in parentheses. Now, can a person be between 2 and 12 and be older than 60 at the same time? No, they cannot. So I'm going to have at least two separate inequalities. One for children between ages 2 and 12, and then another one for persons ages 60 or older, for my senior citizens. Okay, so let's consider the children first. I can be older than 2 and less than 12, but I can also be equal to 2 and equal to 12. So those are going to be my signs. And my variable is A. So my age, if I am, so A here, well, really, I'll read this from left to right. 2 is less than or equal to A, which is also less than or equal to 12. My second inequality is going to be A. Think about this now. What is my goal? I have to be 60 or older. So A has to be greater than or equal to 60. Now, it's going to be really hard to do on this number line, isn't it? So I'm going to start here at 0 and count by 12s. So the first line is going to be 12. The second line would be 24. I'm going to leave that open, and I'm going to number the next line. That's 36. I'm adding by 12s. This one's 48, but I don't have room to write, so I'm going to jump one and go up to 60, because 48 plus 12 is 60. 60 plus 12 is 72. I'm not going to write that one. I'm going to jump up again by 12. 72 plus 12 is 84. Okay, and now I'm going to put a dot at 2. It's hard to see 2 here, but 2 is probably right about there, and 12. And I'm going to put a dot at 12. And that's one dot. The other dot is at 60 and goes this way, and there's really no ending spot there, right? So that is how you do compound inequalities. Now let's jump to example 4. Let's determine if each of these statements is either true or false, and explain your reasoning. So the first statement is this compound statement. 8 plus 6 is less than or equal to 14, and 1/3 is less than 1/2. Well, what's 8 plus 6? 8 plus 6 is 14. Is that less than or equal to 14? Yes, it is. So that's true. How about 1/3 and 1/2? Well, 1/3, think of it as a pizza. 1/3, if I divide a pizza into 3 pieces, right, and then I choose one of them, that's 1/3. 1/2, take the same pizza and divide it into 2 pieces, and then choose one of those pieces. Which piece is bigger, the 1/3 piece or the 1/2 piece? And you can see the 1/2 piece is bigger, which means 1/3 is smaller. So that's also true. So this is a true statement. Both 8 plus 6 is less than or equal to 14. That's true. And 1/3 is less than 1/2. That is true. So we're talking about a true statement here. How about this one right here? Well, 5 minus 8. What is 5 minus 8? That is -3. Is -3 less than 0? Indeed it is. So that's a true statement. Now, is 10 plus 23 not equal to 23? Well, what is 10 plus 23? That is 33. Is 33 not equal to 23? That is also a true statement. Now, I got an or statement that describes both these. Is this true? Or is this true? Well, they're both true, so this is also a true statement. Now, let's go to these down here. Solve each system and graph the solution on a number line. So in order to do letter C, I need to consider each equation by itself first. So in order to do that, I draw a line down. Oh, I'm sorry, not there. There. And the opposite of subtracting is adding. So I'm going to add 9 to both sides. which means x equals 9. And here, I have to subtract 15 from both sides. So x equals negative 15. So now, again, I got to do some fancy counting. I'm going to start with 0 here and count by threes. 3, 6, 9. So 3, 6, and 9. Negative 3, negative 6, negative 9, negative 12, and negative 15. And I got one dot at each of 9 and negative 15. And I'm done because there are no greater than or less than. It's just equal to, which means a dot on that spot. Okay? Now for letter D, there's a little bit more work. These are both one-step. Well, this is a one-step equation. This is a two-step equation. Let's do that one first. And we're going to do it down here so I have room. 5x minus 8 equals negative 23. Draw my line. And in order to do this, I add 8 to both sides. So I get 5x equals negative 23 plus 8 gets me 15, negative 15, I'm sorry. And x equals, if I divide both sides by 5, 15 divided by 5 is 3, but it's negative 15, so this is negative 3. And then up here, I can just do this up here. Minus 1, x equals negative 11. So now I'm going to start with negative 11, negative 10, 9, 8, 7, 6, 5, 4, 3, 2. So this is negative 2, negative 3, negative 4, and so on. So negative 11 is right here, and negative 3 is right here, and I have graphed two solutions on the same number line. Let's turn to the second page. Now I am going to graph the solution set to each compound inequality on a number line. So I got negative 8 is my number of choice. I'm going to put that in the middle. Okay, so x is less than negative 8 or x is greater than negative 8. So let's do this one first. Now, because it's less than, it's an open circle at negative 8, and all values less than negative 8 are true. Okay? Another way to do this is, or I'm sorry, not another way, but the other statement is x is greater than 8. Well, in order to do that, I would have to circle x, or I'd have to circle at negative 8, which I already did. I don't need to do it a second time. But what I haven't done is I haven't shaded in the area where x is greater than negative 8. That would be over here. And that is graphing the solution set to those inequalities. Now, I ask you, is there another way to write that? Is there another way? How about this? With a cross through the equal sign. Is this also the solution set for x is not equal to negative 8? Think about that. Now I got this on a number line. My important points are 0 and 10. So let's do that. Let's number these. Let's see. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to put 0 here. And I'm going to put 10 here. That means 1, 2, 3, 4, 5, 6, 7, 8. Oh, no. I screwed up. Let's put 10 right there. And this goes on. Okay, so now I am doing 0 is less than 10. So let's do that half first. Well, 0 less than 10, I do a circle at 0. And then I do, remember, if 0 is less, not 10, 0 less than x. So now I'm shading the values of x that are Remember, if 0 is less than x, that means x is greater than 0. So I'm shading in the greater values than 0. But I don't want to go too far because I got this guy to worry about. I got x is less than or equal to 10. So because of the less than or equal to sign, I do a dot, a filled in circle at 10, and I shade in to the left of that, and I complete the line. And there is my inequality graphed. Now, in order to be really good at inequalities, we need to go backwards on a number line. So I'm given here is a number line with the shaded in region. Now, I'm going to choose x as my variable. My endpoint over here is -2, so I'm going to put -2 over here, and I'm going to put 5 over here. Now, think about this. All these values are greater than -2, right? So -2 is less than x, but it can also be equal. I can tell by that filled in circle. So I put a less than or equal to sign, right? And I can also do the same thing on the other side. All x values less than 5, or, because that circle's filled in, equal to. And there is my answer for letter G. Lastly, letter H. Now, in order to tell you how to do letter H, let's go back to G. I got one region. Therefore, I need one inequality statement. Here, I have two regions. I'm going to need two inequality statements. The first one, let's do, is for this region. Well, -2, so x, all these values over here are less than -2. So I'm going to do less than -2. And because it's an open circle, I don't put the equal sign underneath it. Okay, so that's my first statement. My second statement here is +5, and x is greater than. So all these numbers over here are greater than +5. And again, because it's an open circle, I do not put the equal sign underneath. And that is my second statement. So this is my answer for letters G and H. Thank you for your time.